First, and what has proved to be the most important one, is the drawing of the arrowheads. And with so many discussion, uh, this could still not be perfected. I mean, even after fourth assignment, I'm seeing people do something like this, okay, or something like this, okay. And at times, people do it correctly. So, as we discussed earlier, the width of the arrowhead to the length, that ratio should be 1 is to 3, or L is to W is 3 is to 1. And of course, this should be darkened. Now, of course, I'm drawing on a computer screen and my drawing is not very accurate. Okay, in the sense that these are not very straight. Okay, but this is the correct one. Now, when I see this type of the first category of arrowheads, okay, uh, whatever marks has been reserved for arrowheads, you basically get 0 for that. If you do this, I will give you some marks, okay. And then there are people who have done somewhat like the correct aspect ratio, and for some of the cases, and for some of the arrowheads, they go back to this one, okay. In that case, I have probably given you, uh, if 2 marks is reserved for arrowheads, I have given you 1.5, okay. And uh, it one more thing that matters along with the aspect ratio is that, let's say you are, this is the the typical dimension of your objects, okay, and you want to show the dimension of this width, okay. Imagine this is a sectional geometry and you are interested in showing the thickness, okay. Oh, actually, that's not a good example, okay. Imagine you are trying to show this thickness right there, and some of you have actually made arrowheads this big, okay, which is in correct aspect ratio, but uh, the size should not be as this big as well, okay. um, so that is also not suitable for uh, for the typical dimension of your objects, okay. So depending on the type of page that you are using, and what are the typical dimensions of your object, the arrowhead should also, uh, the size of the arrowhead should also matter, okay. So this is with the arrowheads, this type of mistakes have been seen, okay. And majority of you have deductions. Majority of you who have any deduction is because of the arrowheads. And so that is the first category, okay. Then the second category, what I'm trying to say here is, if you can perfect your arrowheads, your grades can improve significantly. Number two is line thickness or line width. Now there are different aspects of this. First of all is that you should be in a position to distinguish between a thick continuous line and a thin continuous line, okay. Both should be equally dark, but one of them should be thick, the other one should be thin. Okay, and none of them should be smudgy. Okay, apart from that, the uniformity of the thickness also matters. Okay, and I do understand the problem. Okay, particularly when you are drawing a circular hidden line, let's say. Okay, and of course, most of you are trying to do that, most of you, with the help of the compass itself. Okay, and with the compass it is very difficult. Okay, whether you are drawing a hidden line, or for example a center line for drawing the PCD, pitch circle diameter. Okay, or a simple thin circular line. Okay, uh, that becomes a problem. Okay, particularly with hidden line and center line, it becomes a problem. I do understand that it's not possible for you to maintain the uniformity. Okay, so my suggestion is that what you can do is you can use the compass to lightly draw a circle. Okay, and if you are drawing a hidden line, okay, so the smaller segment that you can draw freehand on that circle. Okay, if you try that, I can assure you that your uh, thin circular line would have more or less the uniform thickness. Okay, you can use one of those pencils that you can put lead on. Okay, so you can use that to draw hidden lines. Okay, but you can just put the outline of the circle with the compass. So on top of that, you can put the hidden lines. Okay, and same goes for the center line. Okay, so some of these issues are seen. Okay, and what I mentioned was that there are, first category is thin line, then there are thick lines, which is basically the solid thick lines, which would basically give you the outline of a solid geometry. Okay, continuous thick lines. Then there is a third category of thick line that you'd use to draw the center line of a, I mean the edges of the center lines of a cutting plane, or for example it's a half plane. So wherever there is a turn, there is a change of angle, you put those thick lines. Okay, so to draw cutting planes, we would use thick lines. Okay, and we would use the same thick line to draw, I'm sorry, not this one, to draw the arrowheads that essentially represent the cutting plane. Okay, again my drawing is not very correct. Okay, so these thick lines are of different thickness than the thick line that you use to draw the solid boundary. Okay, and and the thick line that you use to draw the border and the margin, that is also thicker line. So you can think of a thin line, thick line, and a thicker line. Okay, and don't take these thicknesses that I've drawn literally. All I'm trying to say is that if you take this to be about 0.25 mm, okay, now you might argue that I'm using a 0.5 uh, diameter pencil, or pencil lead. Okay, how can I draw 0.25 mm? You see, if you already know that you're not using the entire thickness of the lid, you can use one corner of it. Okay, then you can probably approach the half of the thickness. Okay, and if you take this to be around 0.5 mm, okay, then this thickness should be even twice of that. Okay, now it's not mandatory to use these dimensions, these values, 0.25, 0.5, and 1. But I think these are possibly more accessible to you. I mean, going for 0.15, 0.25, and zero point 0.5, okay, would be a little difficult with uh, this 0.15 being really small. And one more thing, that this doesn't also require you to be having a ratio of 1 by 2, going from thick to thin line. Okay, but but that way it is rather simple and easy for you to maintain, and also it is easy for me to distinguish. And I know some of you mentioned, and correctly mentioned rather, that the photographs are not looking accurate enough to give me the distinction between thick lines and thin lines. I agree, but still, going from the border to the thin line, I can still be able to see whether or not they are distinguishable. And also, as I mentioned, the uh, the circular lines, particularly, there I have seen issues with maintaining the uniformity of the line thickness. I'm not saying that that issue is not there with the straight thin lines, but it is more so with the circular lines. Okay, um, but I'd still maintain that the line thickness has been a minor issue as compared to arrowheads. Now, the next the next category is the borders and the title block. And if I have reserved 2 marks for this, okay, I mean more than 50% of you have got 2 out of 2. Okay, mostly the border and the title block are fine, except for that line thickness issue. Okay, they have been mostly perfect. But then again, there are some issues. Okay, for example, in some of the assignments, some of you did mention uh, uh, one segment in the title block as scale, but then you didn't write any skill, you didn't mention any skill. Okay, maybe you use some skill, but you didn't mention to put it there. Okay, number one. Number two, if you recall, I asked you to use block letters. Okay, if you cannot do engineering lettering, it's not required, rather it would be asking too much, okay, for you to do engineering lettering in the title block. But ideally, that's what should have been done. I would expect you to put block letters there. That, I think, not many of you have followed. Okay, but still has been only minor deductions. Okay, I mean the lowest mark anyone has got in border and title block out of 2 is 1.5. Okay, that is the lowest. So there is not a lot of thing that is to be discussed here. Okay, so you're mostly doing fine over here. And number four is completeness. Okay, which means whether or not the drawing is complete. The issue is that what would be referred to as complete. Okay, mm, for example, if you are drawing a bolt or a stud, and there are certain segments to it. Okay, so let's say this is the shank of the bolt, and I'm just drawing one portion of it, hence the section. Okay, now this end would have certain features. Okay, obviously it would not look like this, it would not be this. Okay, like the way that has been represented in the book. Okay, there is certain way you are supposed to draw a metric thread, and this is how you do it. So let's say this is the outer diameter, so it's an internal thread. So let's say that outer diameter is d. Okay, so then we need to figure out how much is the core diameter, and that is you can check what is the, you can take approximately to be 0.85 of d. Okay, and and then we need to draw. So let's say this much is the, from somewhere over here you are showing a dimension of the bolt shank. Okay, and I'm using broken lines to represent that the dimension goes, further down. So this is where it ends, right? So it would be ending with a span of the core diameter. So this dimension is, you don't actually have to put that. If you mention this is a, M16 thread, that is all implicit to it. So you can, this dimension should be d0. Okay, and this d diameter continues, but from this end you need to draw sides with 45-degree angle wherever that intersect, which means that would be intersecting at 0.15 d by 2. Okay, that's what it would be intersecting. So wherever that intersect, that 45-degree angle, that's up to which the outer diameter continues. Okay, now the thread is represented by the two lines drawn from d0 parallel to the shank of the bolt, and actually you join these two corners as well. Okay, so there will be two tiny 45-degree right angle triangles. Okay, and this part continues. Okay, and let's say you also know the length of the thread, and let's say that there is this much. Okay, so let's say this is the end of the thread, so that is the end. But then these two lines continue at 30-degree angle further to meet the outer diameter. Okay, so this is how we represent the metric thread. Okay, so what I have seen instead is, of course, some of you didn't have the textbook uh, in the previous, I mean, in the first two assignment, during the first two assignment, and some of you just followed whatever was there in my PPT, and you simply darkened this, just like this. Okay. Also, in some cases, I mean, this is so there are actually two categories for which there has been deduction. So one is the completeness, the other one being the correctness. Okay, and they kind of go hand in hand. Okay, because in most of the cases, if it is not complete, it's also not correct. So uh, so 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 this is one thing. Then there is another thing which would actually be, somewhat representation of incorrectness, which is, imagine there is this cylindrical hole and I'm actually drawing the section. Okay, and let's say through which your stud or bolt passes. And obviously there is a clearance, because in the end there will be another nut, okay, beyond this point, which would be attached to your stud or the bolt. Okay, so there is obviously clearance. And actually, because it looks somewhat like this in the PPT, which is created by scanning a diagram from the book and then also sharpening that diagram so that you can visualize that. So it somewhat looked like it was dark, okay, and some of you simply made it dark without realizing what it actually was. Okay, now this is how it is supposed to look like, not like this, but this part also continues. Okay, so imagine this is the geometry in the isometric view. With a cylindrical hole, and also imagine this is the plane along which you are making a cut. Okay, and then you are trying to look at it from the front view. What would you see? Do you simply see two rectangular sections? Wouldn't you also be seeing this cylindrical surface behind? Wouldn't you be also seeing this cylindrical surface, okay, but as a rectangle? So basically this cylindrical surface that appears over here, and that is no section, that is just a solid rectangle that you would be seeing there also. I mean, this type of mistakes is uh, so many of them are there. Okay, for example, with the Palmer block there is a oil hole, okay, and I'm assuming it is somewhat like this. Okay, and then it meets a cylindrical surface, and these parts, let's say for the oil hole, these are the sections. But what about the rest of it? Is it like totally disconnected islands? No, it's the same geometry. Use your imagination. These parts are actually there. These lines are actually there. Okay, I mean, in isometric view, this is what they look like, right? Again, my drawing is pretty inaccurate. Okay, but I still hope that you get the idea. Okay, so if you're looking at this section from the front view, you should also be seeing all those circular arcs which are part of cylindrical surfaces, okay, as straight lines, and all the cylindrical surfaces as rectangles. Okay, and this conical surface in the middle, between two cylinders there is a conical surface in the middle, that you would be seeing like a trapezoid. Okay, and these are all solid lines representing the outlines of a geometry. Okay. So that is another form of mistake. Next comes your bolt heads, be it hexagonal or square, okay, and nuts. Now hexagonal bolt heads and nuts are basically the same. Okay, it seems to me for you the nuts are like this. I don't understand how could one geometry look like this. What did it look like in 3D? You have to understand how the nut has been created. Even so, initially, imagine, so you all had fitting shop, right? Didn't you all have fitting shop?
Yes, sir.
Okay. Didn't you create a nut there?
হ্যাঁ স্যার, ওখানে আমাদের দুটো সাইড করানো শেখানো হয়েছিল, বাকিগুলো
Okay.
করানো টাইম হয়নি।
Okay. But you still get the idea, right? So you started, and I'm trying to draw isometric views again on a computer screen. So you started with a cylinder like this, right? And you basically chisel out, okay, 6 faces out of it. So so if you chisel out 6 faces out of it, now it is a hexagonal prism, right? So you created that prism, right? At first you created that prism. Okay. Acha. Now of course, then uh, then with the core diameter, drilling would be done. Drilling with the core diameter, that is the smaller dimension. So that is what would be visible. And then threading would be done with the D diameter because it's an internal thread. Okay. So the threading that you are supposed to represent on a, if it is if you are drawing a top view, that's what you are supposed to represent. A 3/4 circle. So this 3/4 circle there represents there is a thread. Okay, it's an internal thread. That's what it represents. Now I'll come to that later. So imagine a circular hole has been drilled. Okay. Now that totally remains hidden. So that circular hole is the core diameter, but then you have drawn the thread. So you are not supposed to draw the hidden line to represent that circular hole. Okay, because the this thickness, size of this side, okay, that itself is D. Okay, so from the front view, this would look like D, and this would look like D by 2 because cos 60 is half. So it would look like D by 2 and this is also look like D by 2. So basically all I'm trying to say here is this length is 2D. Now what would be done is, you see these corners are really sharp. So they would be chamfered. So basically you take a tool, okay, and keep it at an angle and simply put it near the corners. And you would be rotating this, going to be bolt component, going to be nut component, and then you put a file, let's say, okay, this is a file that you'd be using to chamfer the geometry. So after the chamfer has been done, so uh, this corner would be slightly lower, right? Same goes for over here. Same goes for over here. But the sharpening are that chamfering is only done at the maximum diameter, that is D. Okay, so only the corners would be lowered. But if you take this chord, okay, its middle point is actually the furthest from the file of the outer surface. That is the furthest point. Therefore, there is the least amount of chamfering. Okay, so that corner is, that point is still in the same position. Okay, so now if I draw a circle with the midpoints of the chords, that circle is in the same plane. Okay, so when I look at it from the side view, I would look at that circle going from the middle of this. Okay, so touching this, this, and this. Okay, so that red line there is the circle going from middle of this, middle of the left arc, passing through the middle of the central arc and going to the middle of the right arc. And then you are supposed to join that point and this corner right there. Okay, and actually you are supposed to draw the nut like this. So first draw a rectangle of 2D, and let's say the thickness of the nut actually varies. It goes from 0.8 D to D, okay, for a regular nut, then 0.6 for a lock nut. Okay, so it is some D, right? Let's say 0.8 D. Okay, make a rectangle out of it. Then divide this 2D into 1:2:1 segment. Okay. Okay. And you are already been given the the radius of the chamfering, which would basically tell you. So you basically draw an arc with this as one of the points on the arc, and along the center line you can use that radius, so that R is, let's say, 2D for you. I don't know what that has been given in the textbook. So draw an arc with that radius. If it is
So
2D, with that
1.5D there was.
1.5D, so that would be somewhere over here. Okay, so that is the radius. That R is 1. So draw that arc. So that is the second vertical level. Okay, now this is where you would see this corner. Okay, so basically take that point, okay, and join the middle of this. Same thing about here. Okay, so by this time you have your nut looking like this. Okay, with this arc going like this. Now draw an arc, and you are free to do that using your hand, which is tangential to this line and meets over here. Okay, so that way you have your nut completed. Okay, and it's not what some of you have been drawing. Okay, a regular nut, something like this, and a lock nut, something like this. I don't know what sort of geometry that would be. Okay, one more thing regarding correctness. Let's take the gland bush or the neck bush, for example. Now, in the book, when there is an assembly drawing, this is what it looks like. Okay. But when you are drawing a detailed drawing, think about what the component actually is. So it basically, in the bottom, there is a cylinder, which is this portion. On top of that, there is another cylinder, but the internal surface is actually conical. Okay. So the geometry is something like this. In 3D or in isometric view. And you are trying to take a section of this geometry. Sorry. So imagine when it is split into half, you would be seeing this edge, then this smaller diameter or smaller radius. Sorry. To which it converges to. Then, of course, the section that you are seeing in your assembly view. Okay. Would it not be something like this? Okay. Now imagine you are trying to look at it from the front view. So you see, so this is, say, arc number 1. You see that arc as a straight line. This is arc number 2. You look at it as a straight line. And this third arc there, it becomes 3 over here. And that's when the drawing is complete and correct. Okay. So issues like this, I have been seeing over the assignments, and if I simply let you repeat that, for those who have been making that mistake, you are never going to be able to, achieve full marks in those segments. Okay. So I don't recall anything else, anything major. Okay. So maybe these are some of the things that you can look at. এই অবধি কি বোঝা গেল?
হ্যাঁ স্যার। স্যার একটা জিনিস বলার ছিল, ফোনে যখন
হ্যাঁ।
ছবি তুলি তখন ছবিটা খানিকটা হেজি হয়ে যায়, মানে কিছু কিছু দিকে। তো সেই
হ্যাঁ,
লাইনগুলো দেখে মনে হয় ওটা মানে ওই হাতে লেগে যদি লাইনটা স্ম্যাশ টাইপের হয়ে যায় তাহলে যেমন হয় অমনি দেখতে লাগে, বাট ওটা অ্যাকচুয়ালি চোখে ঠিক আছে, বাট ছবি তুলে ওটা অমনি হয়ে যাচ্ছে। তো এটা কি করতে পারি?
ওটার জন্য আমার মনে হয় না খুব বেশি ডিডাকশন হয়েছে, কিন্তু যেটা বললাম যে ইফ ইউ আর ড্রয়িং ইট উইথ আ কম্পাস and or if you are even drawing it with a scale, but let's say the uniformity of the line is not maintained. Okay. It started with certain thickness and then or even darkness. Okay. And then ended with something else. There have been some deductions, and also the unlike arrowhead, the line thickness as I mentioned, is not the major reason for deduction. Okay. So, for example, in Arrowhead, some of you did get 0 even after the fourth assignment. Okay, but with line thickness, you have the lowest mark I believe anyone has got is 1. Okay, and since you mentioned that condition, that issue with photographing, so I have been a little lenient with the line thickness as well.
Excuse me, sir.
Yes.
Sir, can you please extend the date of submission of the next assignment till Sunday?
Next assignment, that means pipe joints.
Yes, sir.
I mean, I is it? I mean, pipe joints are quite simple, right? So, and they were actually due this Sunday. So and because I wanted to have this session, I actually extended that to Thursday next week. Um,
Sir, we are
I'm
going
not.
to have
would be
an
good, sir.
assignment of AutoCAD as well. We are going to have a sort of test on that. So if you could spare some time for us, it will be very helpful.
Okay. Acha, how much time will we get before the session dissolves?
So 15th May, I think, is the last date.
15th May. Okay. Okay. So about 4 weeks. We'll be having about 4 weeks. Okay. Okay. So maybe
Sir.
we. Yes.
Sir, there was also a request from some of us that if we could do the assignment in AutoCAD.
Okay. There is one problem. Okay. With AutoCAD, I mean, it's not going to be easy for me to check whether it is one person doing the assignment or more than one. I mean, and I'll tell you this, that I have seen with hand drawing, I have seen 3 identical assignments. So basically, one person or has drawn it, or 3 of them together has drawn it. Then the name and the roll number has been changed, and the photograph has been taken multiple times and has been sent to me, and that's with hand drawing. Okay, you do understand that I'm not able to take a class, in a regular setup. If I were able to take the class in front of computer terminal where we are doing it in AutoCAD, okay, so there I can check that everyone is working on that assignment. Okay, I mean, what issue should I have with anyone copying from anyone else is that rest of you, okay, are working hard on it, and I need to know that I'm being fair to every one of you. So that it not be possible with AutoCAD when you are doing it on your own. Okay, if it were a class assignment, then it would have been okay. Achha. But with hand drawing, at least I can say that I can at least expect that it would be. You see, one more thing with hand drawing, drawing of each individual person would be different. But with AutoCAD, mostly the drawings are identical. Also, if you want to do slight changes, probably let's say you want to draw one component in the left and the other component in the right, and let's say the other person copies, and it is very easy in AutoCAD to put the component in the right to the left and the left in the right, simply copying and pasting it or using move. Okay, so that way it would not be possible for me to be fairly evaluate your performance. Okay, so that's why it is not as of now I'm not favoring the idea of using AutoCAD, but I do agree that our class should have been in AutoCAD mode, okay, in CAD mode. So I would appreciate if some of you, okay, so your AutoCAD assignments would not be evaluated, it would not be graded, but if you want to submit on your own, so it doesn't carry any marks, but if you want to submit just for checking, okay, and just for your own interest in AutoCAD, because this task technically should have been in AutoCAD, so you can draw it in AutoCAD, the next assignment maybe, okay, along with your hand drawing, okay, and then submit. That is fine by me, and I'll be happy to check your assignment, okay, and if you want to practice, that purpose would also be served.
Sir,
Sir,
so
এখন
can
আর
you extend or not till Sunday?
Sunday, okay, so maybe we can extend that.
Okay, sir. Thank you.
Sir, can you please
Yes.
show the individual marks of each of the assignment and the marks division so that we can know exactly?
I'm see, first of all, these are not final marks, first of all, okay, and I'm also not sure whether or not I can show you the final marks. I'm actually not willing to show the final marks, okay, but you can still have an idea of approximately what is your marks so far, right? Even from the percentile you can get whatever is your approximate marks from that graph, okay, so you can think of that your uh, approximate marks from that chart itself, okay, is going to be very close to your your exact marks, okay, but you'll have to do that effort, okay. uh, mm, and regarding the graph that I sent, the y-axis is the percentile marks. So if you have your percentile marks from y-axis, bring it to the curve, okay, and wherever the curve points on the x-axis, okay, that value is actually your the actual marks.
Sir, that did not include the stop valve assignment.
That did include the stop valve assignment.
Oh, okay, sir.
Sir, I was asking if we can see the marks division, like if we lost it for arrowheads or for line thickness, like that.
Yes, sir, it will be helpful, sir.
স্যার লাস্ট
But
টাইম
if you
যেমন
got
করে আপনি
that,
দেখিয়েছিলেন, ওটাতে
like,
আমরা
it
বুঝতে পারি
will
যে
be
কোন জায়গাটাতে ভুল হয়েছে।
Okay.
I think no one are having problem for seeing their marks.
Okay. I'll show you the marks for the last assignment. There is a stop valve assignment, okay. Okay, so the thing is, I didn't think that would be really important, because we already discussed about what could be the possible reasons for deduction. As you can see, in most cases the reason for deduction has been the arrowheads, okay, and minor deductions with line thickness. Okay. Border and title block, hardly some of you had any deduction. But then again, in these two parts, completeness and correctness, there has been major deductions. One more thing, in the stop valve assignment, I saw some of you draw a separate stud. Then there was another column for supporting between the bridge and the body. I would like to tell you that that is the same stud with two. It's just a single component. Okay, so it's not a hollow cylindrical column shape that has been put on top of the stud. It's just a single component. I hope you understand what I'm talking about. So that has also resulted in some of the reductions in this assignment. And that is very particular to the stop valve assignment. Okay. So is it clear now?
Yes, sir.
Okay. So therefore we'll meet on next Thursday. And on next Thursday, I'm hoping to discuss about tool head of shaping machine. Okay. And after that, we'll see what other assignment we could do. Okay.
Thank you,
Any
sir.
other query? Okay, so we'll meet on next Thursday.
So the next submission for this week's assignment is on Sunday, coming Sunday.
No, I think some of you requested for next Sunday.
Okay, sir. Thank you, sir.